Hi class, welcome back to part 8 of our module 2 online discussion for the topic of strain. So from your module, we have here sample problem number 5, the horizontal steel rod. So we have here a horizontal steel rod, 2.5 meter long, and its cross-sectional area is 1,200 mm squared. Is secured between two walls, so it is secured on both walls. If the rod is stress-free, so there are no external forces that are acting on the rod at 20 degrees Celsius, compute the stress when the temperature dropped to negative 20 degrees Celsius. So from an original of 20 degrees Celsius, it became negative 20 degree Celsius. Assume that for number 1, the walls do not move. Okay, so if we are to redraw our free body diagram, it would look like this. So imagine from a 20 degrees Celsius, it went down to negative 20. So nag-cool down yung material natin. So if the material is subjected to low temperature, the tendency for the material is to compress or to contract. Okay? So therefore, the deformation due to temperature is negative. Okay? Nagko-compress yung ating material. But of course, hindi lang naman basta-basta magko-contract yung material natin. That will be counteracted by its mechanical property. So that would be the deformation due to P or the force P. Okay? So if I am to redraw that, ito yung ating rod. Hihilain pa rin siya pabalik. Force, since it is in its equilibrium state. Okay? So, ang mangyayari dyan, hindi naman siya masisira or mapuputol due to temperature shrinkage. Okay? So, this is force P. Okay? From this figure, we can say that gamma T is equivalent to gamma P. Okay? From our discussion, the gamma T or the deformation due to temperature or the thermal strain, thermal deformation is equivalent to alpha delta T times L is equivalent to the deformation due to the force, and that would be PL over AE. And since we are interested in solving for the pressure, we know that stress is equivalent to P over the area. So substituting, we have alpha delta T times L is equivalent to the stress times L over E. Okay? So since these two are the same material, L will cancel out. Okay? So stress is equivalent to E times alpha times delta T. So substituting the value, our modulus of elasticity is equivalent to 200 times 10 raised to 9 times our alpha or the coefficient of thermal expansion. We have from the problem 11.7 times 10 raised to negative 6 per degree Celsius times the change in temperature. Okay, so dito baka malito kayo. Let's check. Imagine from 20, if we are to draw it on a line, from 20, it went down to negative 20. Therefore, the change is from 20 going down to negative 20. And that is equivalent to 40 degrees Celsius. So Celsius will cancel out. So we will be having 9 point, rather it is 93.6 times 10 raised to 6 pascals, or that is equivalent to 93.6 megapascals. So that is the stress. Now for the second condition from our given, if the walls move together at a distance of delta is equivalent to 0.5 mm. So for condition number 2, if we're basing it for compatibility, okay, so condition number 2, we have here the change which is equivalent to 0.5 mm. We will be having the deformation due to temperature is equivalent to the deformation due to force P times, plus delta. Okay? So we know that gamma T, that sigma T rather, no, it's gamma. Gamma T is equivalent to alpha delta T times L is equivalent to the stress times the length over the modulus of elasticity plus delta. Okay? We are interested with our stress. So, simplifying our equation, we will be having alpha delta T times L minus delta is equivalent to stress times L over the modulus of elasticity, cross multiply. We will be having alpha delta T times L minus delta divided by L times E, and that is equivalent to sigma. Okay? So substituting the values, sigma is equivalent to what is lambda, ay alpha. Alpha is 11.7 times 10 raised to negative 6 times delta T of 40 times the length of 2.5 meters minus 0.5 divided by 2.5 times the modulus of elasticity, which is equivalent to 200 times 10 raised to 9. Therefore, sigma is equivalent to negative. No, it should not be negative. Wait. This should be in meters. Take note that this is in mm. So to convert that, that would be 0.5 times 10 raised to negative 3. And that is in meters. Okay, so palitan natin yung 0.5 times 10 raised to negative 3. Therefore, it is 50. Sigma is equivalent to 53.6 megapascals. So that would be the stress if we are considering the movement of 0.5 mm. If we are to plot it here on our free body diagram, that would be gamma due to temperature, and that is in compression. Then here we will be having gamma P in tension, but due to movement there will be delta, which is also in compression. So there was a movement. So this is the free body diagram. Next problem would be problem number 6. Okay, So from your module, we have here figure A shows a homogeneous rigid block weighing 12 kips that is supported by three symmetrically placed rods. So we have here three symmetrically placed rods. The lower ends of the rod were at the same level before the block was attached. So magkakapareha sila. Determine the stress in each rod after the block is attached and the temperature of all bars increased by 100 degree Fahrenheit. So the temperature increased by 100 degree Fahrenheit. So we are to determine the stress in each of the rod after placing the load, which is 12 kips. If we are to draw the free body diagram, it would look like this. So we will be having a force on the steel, force on the bronze, and force on the steel. So there will be two deformation. The first deformation would be caused by temperature, while the second deformation would be caused by the force P. Okay? So from compatibility, we can say that the deformation or gamma due to temperature of the steel plus gamma P of steel is equivalent to gamma temperature of the bronze plus gamma P of the bronze. Okay? Because all of them are carrying the load and they are symmetrical. So the deformation on the steel is equivalent to the deformation on the bronze. Okay? So using Hooke's law, transfer natin dito. Okay, so using Hooke's law, we know that gamma T is equivalent to alpha delta T times L, and that is for steel, plus PL over AE, and that is for steel, is equivalent to alpha delta T times L, and that is for the bronze, times plus rather PL AE, and that is for the bronze. Okay, now substituting the value, we have alpha for steel, we have 6.5 times 10 raised to negative 6 times delta T, and delta T is equivalent to the change in temperature, and that is 100. Okay, times the length, which is 2 feet, times 12 inch is equivalent to 1 foot. So feet will cancel out. Okay, plus P of steel times the length of 2 feet times 12 inch is equivalent to 1 foot, divided by the area, and the area for steel is equivalent to 0.75 times the modulus of elasticity, 29 times 10 raised to 6, is equivalent to, now for the bronze, alpha is equivalent to 10 times 10 raised to negative 6 times the delta T, which is 100, times 2, 3 feet rather, times 12, plus P of bronze is equivalent to P of bones times 3 times 12 divided by the area, and the area is 1.5 times the modulus of elasticity, which is 12 times 10 raised to 6. This term is equivalent to 0.0156. This term here is equivalent to 1.1 times 10 raised to negative 6. P of steel is equivalent to, this term here is equivalent to 0.036. Okay. And this term is 2 times 10 raised to negative 6 P of bronze. Simplifying the equation, we transfer this to the other side of the equation to make it simplified. So we have here 1.1 times 10 raised to negative 6 P of ST minus 2 times 10 raised to negative 6 P of bronze is equivalent to 0.036 minus 0.0156. Okay, so 1.1 times 10 raised to negative 6 P of steel minus 2 times 10 raised to negative 6 P of bronze is equivalent to 0.0204. And this is our equation number 1. For our second equation, we can go back to our free body diagram. Okay. So from the free body diagram, we have from FBD, we have the summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So we have 2 PS of steel plus P of bronze minus 12,000 pounds is equivalent to 0, 12,000 pounds per square inch. So 2P of steel plus P of bronze is equivalent to 12,000. And this is my second equation. So from here, what I'll be doing is transpose this to the other side of the equation. P of bronze is equivalent to 12,000 minus 2 of P of steel. So this would be my second equation. So substituting sub 2 in 1, what is my first equation? You have 1.1 times 10 raised to negative 6 P of steel minus 2 times 10 raised to negative 6 P of bronze is equivalent to 0.0204. So, and my second equation is this. So I'm going to substitute P of bronze. So 1.1 times 10 raised to negative 6 P of steel minus 2 times 10 raised to negative 6 times 12,000 minus 2 P of steel is equivalent to 0.0204. Error yung lumalabas sa nasa-solve ko. So what we need to do is to simplify it further. So we have here 1.1 times 10 raised to negative 6 P of steel minus, distribute this, and that would be equal to negative 0.024 plus, distribute this to this, that would become 4 times 10 raised to negative 6 P of steel is equivalent to 0.0204. Okay, so combine similar terms, then this term, transpose it to the other side of the equation. So we have 5.1, so add this term, and add this term. That would be 5.1 times 10 raised to negative 6. P of still is equivalent to 0.0204 plus 0.024. So P of still is equivalent to 0.0204 plus 0.024 divided by 5.1 times 10 raised to negative 6. Therefore, P of still is equivalent to 0.0204 plus 0.024 divided by 5.1 times 10 raised to negative 6. And that is 8,705.88 pounds. That is for the steel. Now for the bronze, going back to our previous equation, we have 12,000 minus 2 P of steel, and that is equivalent to 12,000 minus 2 of 8,705.88, and that is equivalent to negative 5,411.76 pound. The negative here is indicative that the force on the bronze rod, is compression or compressive. Ibis na na babanat, nagko-compress pa yung ating bronze rod. Okay? If umabot kayo sa part na to ng video lecture natin, then good for you. You have here an assignment. Okay? So, ang request ko lang, please do not share the info na meron kayong assignment because I want to assess kung sino yung mga nagre-review ng mga ina-upload kong materials. So, pag ikaw na umabot ka sa part na to and gagawin mo yung assignment, please stay quiet. Do not share the information na may assignment. Okay? So, that assignment is due Friday, 5 p.m. to be submitted on this email address. I repeat, pag umabot ka sa last part ng video na to, please do not share the info na meron kayong assignment because I want to assess kung sino yung mga natatapos reviewin yung mga ina-upload kong materials. Correction, hindi Friday ng 5 p.m. Rather, it is Friday 9 a.m. on or before 9 a.m. yung submission ng assignment. So, for the format of your email title, please follow this. MEC 2A, MEC Assignment 2 or MEC A2. Then family name, then followed by your first name. Okay, so I repeat, please do not share the info. Thank you.